Good afternoon, students. So today we'll start mathematics classes. So the first chapter which we are going to start is number systems. Okay. So let me introduce myself. So I am Sunit Kumar. So I am your mathematics teacher. So I take maths as well as physics. So today I'll be teaching you mathematics. We'll start the mathematics class. Okay. So today we'll start with the first chapter, that is number system. So you must have studied number system in your previous grades as well. So what are the prerequisites which are required to understand the chapter well today? So first is that you should have a basic understanding of number system. When I say basic understanding of number system, that means you should know what natural numbers are, what whole numbers are, what integers are, and what rational numbers are. Right. So these are the basic understanding which you should have. And anyways, we'll recapitulate all the concept once more. So number line, you should have an idea of number line, that what origin is, and to the right of the origin it is positive, to the left of the origin it is negative, and you should know how to plot these natural numbers, whole numbers, rational numbers, all of this on a number line. Okay. You should also know basic operations on numbers, means you should know addition, subtraction, multiplication, and division of numbers. So these are the things which we have already covered in your previous grade. Now, what are we going to cover today is we are going to understand what natural numbers are, what whole numbers are, what are integers, and what are rational numbers. So all of this we are going to cover today. So first of all, let's understand the number system. So the smallest set is the natural numbers, right? And we all know that all counting numbers are natural numbers, and we represent a natural number by capital N, right? So counting numbers starting from 1 up to infinity, for example, 1, 2, 3, 4, up to infinity, these are all natural numbers. Okay. Then comes a set which is bigger than natural number, means, for which whole numbers, there is a subset of whole numbers is natural numbers. So whole numbers is a bigger set than natural number, and it is denoted by capital W. So all natural numbers along with zero are called whole numbers. So counting numbers along starting from zero are called whole numbers. Then a bigger set is integers. Integers are generally denoted by capital Z or I. So mostly it is denoted by capital Z only. In some of the books you will find I also. So integers are negative whole numbers as well as positive whole numbers along with zero. So other than fractions, all whole numbers, negative part as well as positive ones, these comprises integers along with zero. Now rational numbers, this is denoted by capital Q. Excuse me. So it is denoted by capital Q. What are rational numbers? Rational numbers are all numbers which can be represented in the form P by Q, where P and Q are integers and Q is not equal to 0. So P and Q, that means when you take the ratio of integers, then in that case, it becomes a rational number. And your Q should not be equal to 0. Clear? So all these decimals which are either terminating or non-terminating and repeating, these are rational numbers. We'll discuss this in detail as well. And then numbers which cannot be represented in the form P by Q are called irrational numbers. So examples are square root of all prime numbers. These are irrational numbers. Pi is an example of irrational numbers. And those decimals which are non-terminating and non-repeating, that is also an irrational numbers. Rational number along with irrational number, these two comprise to form real numbers. So real numbers is rational plus irrational. Together, that makes a real number. Is the concept clear of the number system to everyone? One more thing, irrational numbers are represented, denoted by capital T, and real numbers are denoted by capital R. Is the concept clear? So if you have understood the concept, student, uh, you know, you can write it in the chat, or so Sanjeev, you have asked what about I? Okay, so I means, integers you can represent by Z also, capital Z also, and capital I also. Okay, let's go ahead, students. So we'll one by one see the basic definition of this. So natural numbers, as I said, all counting numbers are natural numbers. Starts from 1, 1, 2, 3, 4 up to infinity, and it is denoted by capital N. Right? This we have already covered. Now next, whole numbers. What are whole numbers? All counting numbers starting from 0 are whole numbers. And so example 0, 1, 2, 3, 4 up to infinity. These are all whole numbers. Right? Okay, so imaginary numbers we are not doing right now. Real numbers, and then you have complex numbers or imaginary numbers. So I'll go back to that slide because you have asked this. So let us deal with that as well. So real numbers and then other form, those numbers which are not real, which you cannot plot on a number line, those are called imaginary numbers, right? So imaginary numbers are also called complex numbers, right? Now complex numbers are of the form a plus I times b, where I is basically a form which says that this is imaginary and the value of I is equal to square root of -1, right? Now these things you will study in class 11th. Complex number in detail is in class 11th. We know that till now what we have studied, that square root of positive number is only possible, means you can find square root of 2, square root of 3 and so on. But you cannot find a square root of a negative number. So for example, if I say square root of -4, you cannot find it, right? So in this case, this square root of negative numbers, these are imaginary numbers, right? So till class 10th, when you solve a quadratic equation, right, you will study how to solve a quadratic equation in class 10th. There you will be, seeing that whenever you have a negative number inside the square root, you say that this is not defined, right? Not defined, that means that these are imaginary numbers, okay, which we are going to introduce in class 11. But yeah, we'll keep on discussing all of this. Is it clear? Imaginary numbers? Imaginary numbers is not included in our syllabus, right? This has to be done in class 11th. Sanjeev was asking about imaginary numbers, and that's why I was telling. Okay? Okay, let's go ahead. So we have already done whole numbers, till whole numbers. Let's proceed. Integers. What are integers? So all positive and negative whole numbers, including 0, are called integers. So positive whole numbers, that is, a +2, +3, +4, and negative whole numbers, that is -2, -3, -4. All of this, including 0, are integers. Integers, for example, it is -infinity, then -3, -2, -1, then comes 0, and then positive part of that as well. So these are all integers. It is denoted by capital Z or I. Now, who is going to tell me? Who is going to tell me why are integers denoted by capital Z? I we generally not use. In some of the books you will find, but rarely. Most of the places you will find that integers are denoted by capital Z. Why capital Z? Why not capital A, B, C, or capital D? Anything? Why only capital Z? Anyone who want to answer this question? Because it has 0 in it, or the Z is the last letter in the alphabet. No, in integers you don't have Z. Yes, Subransu, you are correct. So Z comes from the German word Zahlen, which means to count, and that's why integers are represented by Z, because the first letter of this word Zahlen is Z, and this means to count, and so Z is derived from that German word. Is it clear, students? Good, Subhranshu. So this is a fact which we got to know today. Now, rational numbers. What are rational numbers? A rational number is a number that is expressed as the ratio of two integers where the denominator should not be equal to 0. So rational number is a ratio of two integers, right? So integers can be of the form p by q. Now denominator not equal to 0, that means q is not equal to 0. Okay, so it is denoted by capital Q. Rational number is denoted by capital Q, and examples of rational numbers are minus 2 by 3, 4 by 5, 3 by minus 2, 12 by 5, minus 3 by 1, 0, etc. All integers and whole numbers and natural numbers are also rational numbers. Why? Because 2 can be written as 2 by 1. So these are, ratios of integers. So 2 by 1 comes in the form of p by q. So that's why 2 is also a rational number. Similarly, 0 can be written by 0 divided by anything is 0, right? So 0 by 1. So here again 0 and 1 are integers. So this is a ratio of integers and denominator is not equal to 0. So that's why this also satisfies the definition of rational number. And that's why 0 is also a rational number. Okay. So any number in the form p by q, where p and q are integers and q is not equal to 0, is a rational number. Clear? Is it clear to everyone? Okay. Let's go ahead. Now, first question is based on the number system diagram which we saw, right? So what we saw, that natural number is the smallest one, right? Smallest set, and the larger set than that is whole numbers, and a set larger than that are integers, and a set larger than that are rational numbers, right? And rational and irrational together forms real numbers. So that diagram you always have to remember so that you can answer these questions. So are the following statements true or false? Give reason for your answer. First is every whole number is a natural number. Every whole number is a natural number. This is false, right? Because every whole number cannot be a natural number. 0 is a whole number, but 0 is not a natural number. So every whole number is not a natural number. Second is every integer is a rational number. So integer is a subset of rational number. So every integer is a rational number is true, right? All integers, let's say minus 7 can be written as minus 7 by 1. So all these integers, every integer can be represented in the form p by q. So that's why it is a rational number. Now every rational number is an integer. This is again false, right? So every rational number, for example, 2 by 3, this is a fraction. This is not an integer, right? So every rational number is an integer is a false statement. Very good. Everyone has answered. Okay. Let's go ahead, students. Now the question is find 5 rational numbers between 1 and 2, right? So to solve these kind of questions, there are 2 methods to do that, right? One is that you find one by one the number by finding the average, right? So a number between 1 and 2. So what you do is you find an average by 1 plus 2 divided by 2, which is 3 by 2. So you have 1 and 2. So you got a number 3 by 2 in between. You have to find 5 rational numbers. Now what you can do is you can find an average between 1 and 3 by 2, right? So this will be 1 plus 3 by 2 divided by 2, right? So this is 5 upon 4. Okay. Similarly, you can find, number between these two. You can find number between these two and so on. So, this can keep on continuing, right? But this is a tedious method, right? So, yeah, one way is to write it in a decimal form also. Himanshu, you are correct that between 1 and 2, I can write 1.1, 1.2, 1.3, 1.4, and so on. So, I'll quickly, what I'll do is that I'll tell you this also, that there are two ways in which rational numbers can be represented in decimal form. So decimal expansion of rational numbers. So first is terminating decimal, and the second one is non-terminating and repeating. Okay. So what are terminating decimal? So terminating decimal would be 1.5. This is terminating because, it stops after 5. So that's why we call it terminating decimal, right? And non-terminating and repeating is, for example, you have 0.3333 and so on. So this is neither terminating, but this is repeating, right? So which can also be written as 0.3 and a bar over that, right? Yes, repeating and recurring is same. So non-terminating and repeating can be written also as recurring. Okay. So 1.5, if you write it in P by Q form, this will be 3 by 2, and 0.33 bar, 0.3 bar is nothing but 1 by 3. Okay. So I'll write it here. So this is 1 by 3. Is it clear, students?
Sir,
Yes.
can you multiply both the numbers by 10 and then write the numbers between them?
Yes. We are coming to that next method, right?
Okay, sir.
I'll give you a formula for that as well. So what is being asked? So next method is, what is being asked? Find 5 rational numbers between 1 and 2. So because we have to insert 5 rational numbers, we will add 1 to it. 5 plus 1 becomes 6. This is the first step. Whatever number of rational numbers you have to introduce between two rational numbers, you will add 1 to that. So we have to introduce 5 rational numbers, so we add 1 to it. Now what we will do? We will multiply both numerator and denominator by 6. So this will become 6 over 6. And similarly, 2 can be written as 2 by 1, right? And we multiply both numerator and denominator by 6. We have 12 by 6. Now 6 by 6 and 12 by 6, what are the numbers between them? 7 by 6, 8 by 6, 9 by 6, 10 over 6 and 11 over 6. So exactly 5 numbers you will get between 6 by 6 and 12 by 6. So these are the 5 rational numbers between 1 and 2. You can multiply it by any number greater than 6. You can multiply it by 7 also, 8 also, 10 also. At times it is convenient to do it by 10. So you can do it by 10 as well. Okay. But this method will give you exactly those numbers of rational numbers which is required between these two numbers. Is it clear? I'll repeat the step. If we have to introduce, for example, 4 rational numbers between 1 and 2. So if we have to introduce 4 rational number, what we are going to do? We will add 1 to it. This will become 5. Then we will multiply both 1 and 2 by 5 in numerator and denominator. Okay. So this will become 5 by 5 and 2 by 1 when multiplied to 5. This is 10 over 5 And then we can have the numbers 6 by 5, 7 by 5, 8 by 5, and 9 by 5. So these are exactly 4 numbers. Is it clear? Is it clear, students? Yeah. Okay. Let's go ahead, students. So what we saw that there can be n number of rational numbers between any two given rational numbers. So in fact, there are infinitely many rational numbers between two given rational numbers. You can keep on dividing it by 2 till infinity, and you can keep on getting the numbers, right? So between any two rational number, there are infinite number of rational numbers which are possible to introduce between that. Okay? Yes, Himanshu, that is also correct. So you have to, 10 by 10, and you will have to write 20 by 10. And then when you write 10 by 10 and 20 by 10, then you can write 11 by 10, 12 by 10, 13 by 10, 14 by 10, and 15 by 10. And that's how you will get 1.1, 1.2, 1.3, 1.4, and 1.5. Is it clear? Okay. Now, the next question, students. Is 0 a rational number? Yes, we have seen that 0 is a rational number because you can write it as 0 by 1, which is of the form P by Q, where Q is not equal to 0. So that's why it is a rational number. Can you write it in the form P by Q? Yes, it can be written in the form P by Q, where P and Q are integers and Q is not equal to 0. Okay? Before I teach further, students, I'll just quickly remind you, tomorrow we have a proficiency diagnostic test at the same time at which you have joined today. We will send you a link. On that link, you have to give all the details which is being asked there, your email ID, your mobile number, and your name, school name, and everything. So once you have done that, we'll create a login ID for you, which you can use to log in on our platform and take that diagnostic test. That diagnostic test will help you understand your strength, opportunities, hurdle, and weaknesses. And it will also help us teachers to understand your strength areas, your opportunity areas, and accordingly, what we'll do is that in next 1 month, this summer course, we'll plan our classes in the way which benefits you the most. And once you join back school after this summer vacation, you will be able to get the best benefit out of this summer program. Okay, so please fill this form, and there will be calls also made today so that you can give data to the concerned person who calls you on the number which you have shared. Okay, Kavin is asking, can you give an example of this question, sir? Yes, I'll do that. So is 0 a rational number? So as I said, 0 can be written also as 0 by 4. Now 0 is also an integer and 4 is also an integer. So because it is a ratio of integer over integer, where the denominator is not equal to 0, and hence 0 is a rational number. Is it clear? Okay. Let's go to the next question. Now find 6 rational numbers between 3 and 4. Use the same method which we discussed just now. So because there are 6 rational numbers, what are you going to multiply both numerator and denominator with? Tell me. Very good, Himanshu. So because we have to introduce 6 rational number, we'll add 1 to it. We will multiply both numerator and denominator by 7. Okay. So now 3 can be written as 3 by 1. And we can multiply both numerator and denominator by 7. We'll get 21 over 7. And 4 can be written as 4 by 1. We multiply both numerator and denominator by 7. We get 28 by 7. Now, the numbers between them is 22 by 7, 23 over 7, 24 by 7, 25 by 7, 26 by 7, and 27 over 7. So these are the 6 rational numbers which are there between 3 and 4. Is it clear, students? Okay. So let's go ahead, students. Find 5 rational number between 3 by 5 and 4 by 5. Now please do it, and then I'll give you 2 minutes, 1 minute to solve this. This is again like fraction because the denominator is same. So we don't have to do much. We just have to multiply both numerator and denominator by one number more than this. That is 6. So what are the numbers? You can write the numbers. So we have to find 5 rational numbers between 3 by 5 and 4 by 5, right? Okay. So one way is what Sanjeev is doing. He has multiplied both numerator and denominator by 10 straight away, and he has got those numbers. Yeah. So one way is doing that. Other one is what we were discussing. What we'll do, we'll multiply both numerator and denominator by 3 by 5. Numerator and denominator by 6. So 3 by 5 can be written as 3 into 6 over 5 into 6. So this is 18 by 30. And then 4 by 5 can be written as 4 into 6 by 5 into 6. That is 24 by 30. So the numbers which are between 18 by 30 and 24 by 30 are 19 over 30, right? 19 over 30, 20 over 30, 21 over 30, 22 over 30, and 23 over 30. These are the 5 rational numbers which are between 3 by 5 and 4 by 5. Yes, Himanshu, you are correct. Clear, students? Let's go ahead. I'll remove this. Now, next question is, state whether the following statements are true or false. Give reason for your answers. So every natural number is a whole number. Is it true or false? Every natural number is a whole number. Yes, it is true because all natural numbers are whole numbers, because natural number is a subset of whole numbers we have just seen in the number system. Second is, every integer is a whole number. Is it true? Are all integers whole numbers? No, it is not true. Correct. It is false. Why? Because whole numbers cannot be negative and integers are negative as well. So that's why this is false. Every rational number is a whole number. Is it true? No, it is not true. It is false. Every rational number cannot be whole numbers. For example, 5 by 6. This is not a whole number. It is a fraction. So every rational number is a whole number is a false statement. Clear? Let's go ahead. Now, these were all about rational numbers. Now let's start irrational numbers. So as we discussed, what are irrational numbers? Irrational numbers are those numbers which cannot be represented in the form p by q, where p and q are integers. Means if you cannot represent a number as ratio of integers, then we say that these are irrational numbers. So an irrational number is a number that cannot be expressed as ratio of two numbers, two integers. Okay, so it is denoted by capital T. Okay, most of the places you will not find this denotion. So you should always know that irrational number is represented by capital T, right? Any number which cannot be written in the form P by Q, where P and Q are integers and Q is not equal to 0, is irrational number. So cannot be written in the form P by Q. Clear? Now let's go to the next. So these are the examples of irrational numbers. Root 2, root 3, root 15. These are all irrational numbers. Okay. And then pi is also an example of irrational number. Now, some students ask us that pi is written as 22 by 7. This is the value. Then because it is in the form p by q, why do we say pi is an irrational number? Who is going to answer this? Anyone? Yes, Himanshu, correct. This is an approximate value, right? This is not an actual value. That's why means pi is not exactly equal to 22 by 7. It is an approximate value. So basically the value of pi is non-terminating and non-repeating or recurring decimal. So the value of pi is 3.142 and it goes on, right? So you cannot ascertain the final value because it goes on till infinity. So it is neither terminating, it will not terminate, means it will go on till infinity, and it is neither repeating. If it was non-terminating and repeating, it would have been a rational number. But because it is non-terminating and non-repeating as well, that's why it is an irrational number. Okay, so that's why you can see this last example. This is also an example of non-terminating and non-repeating. So you have 0, 1, and then 0, 0, 1, and then 3 times 0 after that 1, then 4 times 0 after that 1. So, 0 is not, there is a pattern, but it is not exactly repeating, right? So that's why we say that it is non-terminating and non-repeating, and that's why it is an irrational number. Clear, students? Is it clear to everyone? Okay. Now, collection of all rational numbers and irrational numbers together is real number, and it is denoted by capital R. So real numbers is collection of both rational and irrational. Okay. So rational and irrational together makes real numbers. Okay. Now, therefore, a real number is either rational or irrational. So we say that every real number is represented by a unique point on the number line. So you can represent every real number on the number line at a unique point. Okay. And also every point on the number line represents a unique real number. So if you draw a real, this is a number line. So let's say this is 0 and this is 1. So all the points which are there between 0 and 1, there will be infinite number of points here. All these points will represent one or the either real number. So every point on the number line represents unique real number, and every real number is represented by unique point on the number line. Okay. So that is why we call the number line as real number line. So the number line which we draw, the horizontal one, that is real number line. If you have to, you know, plot an imaginary number, that will be plotted on y-axis. So this is real number line. And this is your imaginary axis. Okay. So any complex number would be plotted somewhere here. So have you done coordinate geometry? I don't think you would have done coordinate geometry. It is in there in class 9th. So you will understand this y-axis and x-axis. Okay. You must have done this, some part of this in data handling when you were drawing the graphs and everything, right? Okay. Okay. Good. So let's conclude, students. So today, what did we study? We studied about natural numbers. We studied about whole numbers. We studied about integers, right? We studied about rational numbers. Okay. And what's next? So next class when we meet, we'll study irrational numbers, and we'll also study locating irrational number on the number line, how to plot these irrational numbers on the number line. For example, root 2, root 3, root 5, right? Root 7. How do you plot these numbers on the number line? We'll do that in the next class. So when you come for the next class, bring your compass, right? Bring your compass and scale and all of this. So be ready with the compass, with pencil and scale and a notebook when we make all of this, right? So I'll tell you how to draw all of that, and then you can do it on your copy as well. Okay. So thank you, students. Thanks for joining in today. As I said, please, register yourself for the diagnostic test so that, you can take the test tomorrow. And we'll share the same link. So the link which you have been joining in for the class, so same link will be shared with you. You can join in with that link. We'll give you all the instructions of taking the test. You can take the test with the link, joined with that link. And then when you submit the test, you will get a report which we'll be sharing with you. Okay. Okay. So if it is taught to you in the class, so what we are going to do, we are anyways revising. So your concepts are going to be clearer, right? And when there would be many learning gaps which would be there. So all those gaps would be taken care of, right? And we'll delve deeper into that as well. So don't worry, it's revision of what you have done in your grade, and we'll go ahead also, over the period of time in 1 month. Okay, students.